Hi, my name is Edward. I'm a UCL biochemical engineering student. Today we're going to be looking at the electron configuration. This is a relatively simple concept, but I think a lot of people get it wrong just because of simple misconceptions on this subject. We're going to be looking at the conventional way to write electron configuration for elements, as well as looking at a slightly more in-depth advanced way to look at electron configuration and how to write it. So by now you should be confident in knowing the SPDF electron shells. It's important to remember that they hold 2, 6, 10, and 14 electrons respectively. So let's get to our example. Hydrogen is the element that has 1 electron. So how would we write the electron configuration for that? Well, we would write 1s1, seeing as it has just 1 electron. Carbon has got 6 electrons, and so we would write 1s2, 2s2, and 2p2 to make up for the 6 electrons. For sulfur, can you now guess what the electron configuration would be? Exactly. We are trying to basically add up all the numbers at the top, which look like an exponential, to add up the total numbers of electrons in the element. Now let's look at a slightly different example. Let's look at mercury and see what the electron configuration is for mercury. Whoa, that's a lot of writing. So let's try to simplify this to make it slightly easier to write. So we're going to use the noble gases. And what I mean by this is that we're going to use the amount of electrons that each noble gas has in order to add up the total amount of electrons. Remember that mercury has 80 electrons and xenon has 54. We can write the xenon as having the 54, and then we write the rest of the electrons using the conventional way. This is an equally correct way of writing an electron configuration without having to write the whole conventional way, which would obviously take a lot more time. Thank you for watching.